These days, everyone is using an AI IDE like Windsurf or Cursor, even non-coders, to do some incredible things. I feel like the king of productivity when I use these tools, especially with some of the recent additions like documentation retrieval and Claude MCP support. The problem is, even though there are a lot of strengths with these tools, there are just as many flaws. I mean, they hallucinate awful code all of the time, even when you give them extensive documentation and instructions. Ladies and gentlemen, it is long overdue that we get a big upgrade for these AI coding assistants to tackle all of these hallucination problems. And I think I've started to uncover what the next evolution will be for this. And I'm not just talking about incremental improvements, I am talking about a complete paradigm shift. What I'm about to show you is very experimental, but I truly believe is going to be the next wave of innovation for AI coding. And it all revolves around specialized subagents and Claude's MCP. And I'm going to demonstrate it for you in this video using Archon as an example, which is the AI agent that I started recently that builds other AI agents using Pydantic AI and LangGraph, my two favorite frameworks. Now buckle up and just hear me out on this because I'm going to get you on the same page as fast as I possibly can. The problem right now is AI coding assistants are too general. They're the jack of all trades, but also the master of none when it comes to coding with different frameworks, tools, and libraries. It doesn't matter if you give them the documentation for something like a framework, that is not enough. They're still too general. And so that begs the question, what's the solution? How do we get more specialized? Here is the golden ticket that I've started to dream about that I want to share with you in this video. Imagine having specialized agents that are created specifically to code with a certain tool or framework. And these agents can be called upon by the general AI coders like Windsurf or Cursor when necessary. It's the best of both worlds because sometimes you need that general coder, and then other times you need something that knows how to work with the specific framework that you are trying to code with. And this is possible right now because you can define these specialized agents as sub-agents that work as MCP tools that you can bake into all the popular AI coding assistants because Claude's MCP is becoming so widely adopted now. Sound complicated? It's actually not, and I'll show you exactly how to do it in this video. We'll take Archon, my AI agent builder that I mentioned earlier, and turn it into one of these MCP sub-agents and then bake it right into Windsurf. And you could do this with Cursor or any other AI coder. So allow me to demonstrate this for you. I can guarantee that even though this is very experimental and alpha, it is going to light up your imagination with the limitless possibilities that we have here. So we're going to dive right into a demo of using Archon within Windsurf to build us an AI agent. And then for the rest of this video, I'll show you exactly how I set it up. Because Archon originally just started running in a Streamlit interface. And I actually show you exactly how I built Archon in this video. You can check out right here using LangGraph and Pydantic AI. And now we're focusing on the next evolution of Archon, turning it into a sub-agent with MCP right here. So let's go ahead and give it our first prompt. And so right here, I'm saying build me an AI agent using Archon that is able to search the web using Brave. So just starting with a very basic prompt because Archon is still in its infancy here. But if you click on the hammer icon here, we'll actually check this out before we send in the prompt. I have my MCP servers here, which Archon is the only one that I have configured at this point. We've got two tools. We have one to create the thread ID because Archon needs some sort of conversation ID to manage the conversation just like Windsurf does. And then we have our primary tool to actually invoke the creation of the agent or to work on it iteratively with that human in the loop feedback loop that I showed in my first video for Archon. So those are our two tools. Let's go ahead and send in this request. So the first thing it'll do is call this tool to create our thread ID, which is now going to pass into Archon for all future calls. And so it's going to be using this API endpoint that I created for Archon since that first video as well. And so it's making that first request already. You can see that Windsurf is waiting for the API request to finish. And this will take a little bit because Archon has that full workflow where it goes through the reasoner model to create that initial scope for the agent. And then it goes to the coder agent like we see right here that performs RAG to get the Pydantic AI documentation, combines it all together to create that initial version of our AI agent. And then the control is going to get passed back to Windsurf in a little bit here once it finished creating the agent. And so by the way, this is using O3 Mini for the reasoner model right now, and then GPT-4o for the actual coder. And then look at that. We finished our API response right here for our Archon API, and now all the code is passed to Windsurf to then actually create these files for us. So look at how seamless that is. The control just operates so well going between the different agents that we have here. And there we go. It used the code from Archon to build us agent.py. And then just like we have Archon build out the requirements.txt file, and then the tools file, and the .env.example file, it's spitting out all of these because Windsurf is really relying on Archon here to direct it as the specialized subagent for building Pydantic AI agents. And I'm not going to actually show running this right now, but I will show at the end of this video a full example of building out an agent, perfecting it, and actually running it and testing it. But yeah, look at this. Like, I was looking at this right here. Overall, the code looks good. Like, we got our agent right here. The requirements look good. The agent tool for executing the Brave search looks good. We got our env example file with the Brave API key. This is looking absolutely perfect. Just so cool. And I hope you can see that, like, even though this is a very basic example at this point, with both the infancy of Archon and how basic this agent is, I hope you can see that you could make so many different kinds of specialized subagents that you have something like Windsurf or Cursor call into when necessary. And the way that you can tell these AI coders when to use these is just in the description for these tools. Like, I can tell it, like, when you want to build a Pydantic AI and LangGraph agent, then use Archon, and here are your tools for it. And so you have all these descriptions to guide it without having to actually even edit the cursor config or edit the rules for Windsurf. You just have it all defined right here in your MCP servers. So with any new innovation always comes a lot of questions, and I'm sure that you have a couple on this as well. So let me know in the comments if there's something I don't cover in this video, but I'm going to try to address a couple of the big ones that I'm sure will come up right now. I mean, the first big question is, why not just use the documentation feature built right into AI coders like Windsurf or Cursor? I can literally go into the bottom right here and say @Pydantic AI, and then boom, I have the Pydantic AI documentation available, which Windsurf is going to use to fulfill my next request. And I can do @LangGraph, and then boom, I got the LangGraph docs as well. So why not just use this to code my Pydantic AI and LangGraph agents instead of using Archon? And there's two primary reasons for this. First of all, with the whole agentic flow that we have for Archon, having the reasoner model and the system prompts that we have built in, we get this very consistent output for the different files that we split our agent into and just the structure for things in the scripts themselves. And we don't get that with Windsurf or Cursor. You can try to kind of edit the rules and stuff, but really it's more than just the system prompt. It's the whole flow of Archon that produces this very consistent code. I like that a lot, and I don't get that with Windsurf. It produces code that looks very different every single time, and that produces some more errors as well. And that's kind of the second big thing as well, is that the code is always going to be better with Archon. And it might be kind of comparable at this point because Archon is in its infancy, but as we build it out and add self-feedback loops and the ability to break things up into different sections as it's building and really split the problem into small steps, it's going to be so much more robust than just having a general coder spew out all the code at once and then improve on it from there. It's just going to be more of a one-shot and then just make it more robust. You're just going to have such a better starting point using something like Archon and the way that it can leverage the documentation better as well. So that's why we care about using Archon. And then the second big question is, why are we generating this thread ID here? I mean, it's kind of weird. Like, MCP servers are supposed to be stateless, right? Like, you call the tool and then the tool gives you a response and then forgets everything. But in this case, Archon is a sub-agent tool that actually maintains the conversation history just like Windsurf does. Here's the LangGraph graph that we have for Archon. And all of this, like, this is stateful. We have the reasoner that creates the scope and that goes to the coder agent. And then we have this human in the loop where we can actually ask it to iterate on the agent. So it has to maintain the conversation using some sort of identifier to know that this Windsurf conversation maps to this run of Archon that is iterating on an agent. And so we have this thread ID that it creates, and the LLM has to remember to pass that in to the tool. So it has to keep track of this thread ID, which is a little bit uncomfortable that we rely on the LLM for that, but this has actually worked 100% of the time for me, surprisingly. And so then in any future iteration where we maybe tell it to use Archon again to improve the agent in some way, it'll then use the same thread ID so that it's invoking that execution of Archon, going on to kind of that next step in the human in the loop feedback loop that we have here. So that's how I use the thread ID. Again, kind of forced a little bit into MCP, but it works pretty well. And so, yeah, I'm kind of at the forefront of innovation. Like, I haven't seen anything like this. And so, definitely trying to just figure everything out as I go right here, but getting some really cool results. And so, with that, let's dive into MCP a little bit, talk about Archon, and I'll show you how I brought everything together. The sponsor of today's video is Fish Audio, an extremely impressive voice cloning and voiceover solution that is transforming the way that developers, marketers, and content creators create audio with AI. And Fish Audio is not just another speech-to-text tool. It is a state-of-the-art, real-time speech-to-speech model that delivers top-tier realism. Let me show you a demo really quick. Now, from the Fish Audio homepage, you just go to My Voice Library, Custom Voice, and then Build a New Voice. And this is where you can clone yourself in just minutes. You add in your cover image, name, and description. Then at the bottom here is where you add in your sample clips for it to mimic you. Recommended around 30 seconds. And you can even record yourself right here in the UI, so they make it very easy for you. So go ahead and click on Create. In my case, I'm just going to use the custom voice that I already have built here. I'll paste in my kind of silly sample prompt I have here saying Archon is the best AI agent builder. Also, a pro tip, you can change the spelling of things a little bit just to help it enunciate better. And all of this is accessible through their API as well if you want to use it programmatically. So you can change the speed and volume as well, and then click on Create, and then in just a few seconds, it'll generate our audio clip and play it for us. Archon is the best AI agent builder that ever was and ever will be. Don't believe me? Well, why wouldn't you? Fish Audio is designed to do it all. YouTube voiceovers, voice agents, adding multiple languages to your projects, you name it. And at the same time, it is super affordable, 50% cheaper and 2 times faster than 11 Labs, which has been the go-to voice platform for a while now, even though it's always felt very overpriced to me. So it definitely seems like Fish Audio could be taking the crown as the go-to AI voice platform. To say I'm impressed while testing out Fish Audio is saying the least. If you are ready to level up your AI voice game and make your project sound truly professional, head on over to fish.audio, sign up for their generous free trial, and experience the magic of their AI voice cloning for yourself. I mean, you can literally try it out in under 2 minutes, so definitely give it a go, see how well it works for you, and I'll have a link in the description to Fish Audio as well. So the most important thing for me to start with as I show you how I built Archon into an MCP subagent is to give you some context around what MCP is, what Archon is, and how I can combine them together to build this very specialized agent. So first of all, MCP. It is a protocol developed by Claude pretty recently here, just a few months ago, to standardize the use of tools with large language models. So they have this full article that you can read if you are curious, but essentially it's a way where you can create these servers that you spin up that have access to API endpoints for a certain service like GitHub, Google Drive, Discord, whatever it might be. And so essentially this server is exposed to a large language model to give those tools dynamically to an LLM. So when you spin up an MCP server for GitHub and then give it to your LLM in Windsurf or Claude Desktop or whatever, the LLM can now do things on your behalf in your GitHub repositories. It is so cool how fast you can spin up these servers and then instantly give LLMs access to do all these things for you. There's a server for Brave Search, there's one for Google Drive, for your SQL databases, there's all these third-party servers that are created by the community, kind of like Archon is going to be now, so you can do things with JetBrains or Stripe, or you got AWS S3. If I scroll down a little bit, we've got Discord, DeepSeek R1. All of these are servers that we can download right now. They're all open source. I can run them on my computer or reference some API endpoint in the cloud, and then boom, all those tools will now be available for my LLM wherever I'm running it. And so that's what we're doing with Archon. So Archon is an AI meta agent. It is an agent that builds other agents using Pydantic AI and LangGraph. So I've been building it out. Started very recently. I only have one video on my channel on it so far, but essentially I'm developing an iterations to teach Pydantic AI and LangGraph, and then also eventually to build it into a very robust sub-agent that we can use in AI coders to build these agents with Pydantic AI and LangGraph very, very nicely. And so what I'm doing right now with MCP is turning it into a tool that we can give to LLMs like we just saw we did in Windsurf. So essentially Claude 3.5 Sonnet running in Windsurf has Archon as a tool. And so this is the LangGraph graph that defines the full workflow for coding agents with Archon. So we have the reasoner at the start that kind of defines the scope for building the agent and the high-level reasoning, and then it goes into our faster coder agent, which actually produces the code. And then we have this feedback loop right here getting input from you as the user so it can iterate on the agent, and then it gives the final response and instructions to run the agent at the end. And so we package this entire workflow together to give as a tool to AI coders. That is the power of using Archon as an MCP sub-agent. And so now, kind of with that as our context here, I'll actually dive into how I set up the MCP server and hooked up everything with Archon. So this is the Python script for our Archon MCP server. I'm going to go over it at a high level right now. Might do a future video on my channel where I really dive into building a Python MCP server from scratch, but also I'll have the links to the documentation in the description if you're curious to dive into that yourself. You can make servers for both Python and JavaScript. So at a high level here, we're using a fast API with the MCP Python SDK. We have our first tool right here to create that thread ID, again, because Archon needs that to manage the conversation history. And then we have our second tool to actually invoke Archon itself. And the way that we do that is through an API endpoint that I created for Archon. So this is new to version 3 of Archon as well. We have this fast API endpoint that I created that is interacting with Archon in a very similar way to how we did with Streamlit in the last video on Archon on my channel. And then the graph for Archon that I showed in the last video how to build completely from scratch, this remains entirely the same. So there's nothing that I changed in here. We're just wrapping it all up in this API endpoint with fast API that I'm then calling right here in the MCP server. So it's a nice and simple implementation where we don't actually have to use Archon as an MCP server now. I'm remaining flexible for you where you could still work in Streamlit or use this as an API endpoint in some other front end that you make for Archon. You don't have to use it as an MCP server, but I still make it very easy to do so as well. And so actually, if I go into the README here, let me just open the preview for this. The updated instructions for Archon, I show you actually how to run this both without the MCP server setup. So if you want to just do it with Streamlit or with MCP. So I cover both of these. I got these instructions right here in the README to set up everything very, very easily. So you can play around with this yourself in Windsurf or Cursor or Streamlit or wherever. And then the other really important thing that I want to hit on for this MCP server, the way that it works in general, these doc strings that we define at the top of our function definitions. This is very similar to tools in Pydantic AI and LangChain. These actually tell the LLM when and how to use these tools. So this exact string that I see right here, I'll go back over to Windsurf. I'll show you this. Look at that. It is right here. So the definition of the function, this string right here, is actually put into the prompt for Claude 3.5 Sonnet in Windsurf so that it understands when and how to use these tools. And so I can give specific instructions here, like for example, telling Claude that before it can run Archon, it needs to generate a thread ID if it's the start of building an AI agent. And then if it's not the start, it needs to pass in the same thread ID so Archon is managing that conversation. Because obviously, it won't run if there's not a thread ID yet. It has to pass that in as one of the parameters to this tool when it runs Archon. So that is the MCP server as a whole. Again, nothing changed with the graph. Very simple, fast API implementation. Don't need to dive into this overall. And then I also have this neat little script that I have created. I have this in the instructions as well. But it'll completely set up your virtual environment for you, and it'll even generate the MCP config to put into Cursor or Windsurf. So I'll actually pop up my terminal here. I'll even show you that. So this is the API endpoint that we have running right here. But if I stop this and I run the command Python and then set up mcp.py, my virtual environment is already created, so it skips that step. But then look at this. It gives me my configuration that I'd have to put into Cursor, instructions for that in the README. And then it also gives me the JSON to put in the config for MCP in Windsurf or something like Claude Desktop as well. So you run this script, you know exactly what to do to set up your Archon MCP. So I make it as simple as I possibly can for you. All right, so really quick, let me show you how to run everything, and then we'll build an agent from scratch. So going back to the README here, which again is just at the root of the GitHub repository, we have our installation instructions. And so if you're doing it the old way, just interacting through Streamlit and not as an MCP server, again, that is still supported, then you can follow these commands right here. So you just clone the repo, activate your virtual environment, install all your requirements. And if you're using through MCP, you can run this setup script that I showed earlier, which sets up your virtual environment, gives you your MCP config, and then you want to activate your virtual environment as well. And then I have instructions for both Windsurf and Cursor how to include the config that the setup MCP script gives you. And it'll be the same, or at least very similar to one of these two, if you're using something else like Claude Desktop or some other AI coder that supports MCP. And then set up all your environment variables. All of this remains unchanged. Same thing with running this Python script here to actually get the Pydantic AI documentation and then put it in the Supabase knowledge base for RAG. And then using MCP servers, you'll run the API endpoint to expose Archon as an API. Otherwise, you can just use Streamlit directly because that interacts right with the graph instead of going through the API like we do with MCP. So that is everything for running. I'm not going to go through all these commands right now because I hope it's really clear for you. So I have this all up running on my machine already. So now we're going to go ahead and actually test it all out because now we have the full Archon graph packaged together as a tool for Windsurf. And I also want to re-emphasize, like, super important for you to know that, like, this really is just in the first stages of development. I'm going to add so many more nodes and improve system prompts and add in a tool library, like so many ideas I have to make this really robust. But even this is a good starting point. And so let's go ahead, build an agent from scratch, iterate on it, and test it out. So I thought it would be fitting to take the Brave agent we started at the beginning of the video and see that through to completion for our final demo here. So I am building it from scratch, but using the same prompt. So I've got the API endpoint spun up for Archon right here, graph service.py. I'll show the logs for that so you can see things happening in real time as we build the agent. So I'll paste in the same prompt here, use Archon to make an AI agent. So first it gets the thread ID. Now it says it'll ask Archon for help. I just love that. Like, it just shows that, like, this is an agent asking another agent for help, a sub agent, when it knows it has the expertise it doesn't. And so starting with our reasoner model, O3 mini, it's creating that scope, which also includes the Pydantic AI documentation pages it thinks the coder should look at, which it goes ahead and does. So Pydantic AI coder, performing RAG, getting all the contents here to create our AI agent based on the Pydantic AI documentation. And I will be expanding to work with LangGraph later as well, but just starting very simple here with Archon. So now it's generating that final response. Windsurf is still waiting for it, but in just a little bit here, we'll see it flash, and then, yep, there we go. All right, so now we got the final response from Archon, and it's going to take those files and implement them into my IDE here. So starting with the requirements.txt, okay, looks pretty good. Pydantic AI and HTTPX, definitely only dependencies that we do need here. And then we have our agent. Okay, that looks pretty good. It says the model is none, which I don't like that. So it looks like it's pretty good overall. I mean, the Brave search tool looks good. Okay, I like that. And then we have our env.example file for the Brave API key. Looks good. Looks like we'll have to implement an LLM here, but everything else looks good. So I'm going to accept these changes, but now I'm going to use human in the loop because I want to. Let me actually move myself here so you can see me typing right here. I'm going to ask it to fix the first big issue that I see here because model is none. So I'm going to say, ask Archon to fix the model for the Brave search agent. Right now the model is none and I want to use GPT, we'll just say GPT 4.0. So now it's going to use that human in the loop here. And so it's going to invoke Archon using the exact same thread ID. So now going back over to the logs here, it jumps right to the right to the Pydantic AI coder. So it didn't invoke the reasoner this time because we are already within the graph execution within that loop with just the coder agent. So we got the response back from Archon. And now it edited the model. So OpenAI GPT-4. And it should probably be GPT-4.0. So I'll just go ahead and edit this right here. You still want a little bit of human intervention, especially because Archon is such a new implementation at this point. But still really cool. We could see there that it actually used Archon to then update the agent. And obviously this is something that Windsurf probably could have done itself, but I just wanted to give a really simple example here for human in the loop with Archon. And so yeah, this is looking pretty good. What I'm going to do right here is test this off camera, fix up any little glitches that I have here, and then we'll go ahead and run this with a Streamlit interface. So I'm back after fixing just a couple of things. It did not take much to get this to a working state, and I'll even show in a Streamlit interface that I made really quick for this agent, everything working perfectly. So the main thing that I had to fix, obviously, besides getting everything with the environment variable set up, because I had to create a .env and then it wasn't using that in my agent, is it didn't really have the right URLs and parameters for interacting with the Brave API. So in the end, it didn't actually mess up with things related to Pydantic AI or LangGraph. It was a hallucination with the Brave API, which I didn't give the documentation for. So can't really blame Archon. It would have been the exact same thing with Windsurf. That's why a tool library is going to be so useful. So I could have like a pre-made Brave tool that it would just pull and use right there for the Pydantic AI agent. So that's all I had to fix up. Everything else I kept exactly the same. And so then I created this Streamlit interface that I just ran right here with command streamlit run and then streamlit UI.py. Obviously added that as a dependency for the project as well. And then boom, we now have this chat interface right here for our agent that was almost completely generated by Archon, with Windsurf just calling it for the help to make this agent. So I can ask it a question like, what is the net worth of Elon Musk? The kind of thing that an LLM wouldn't know by itself because of its training cutoff, so it's going to be leveraging the web search tool here, which it did. As you can see right here in the logs that it made the request to the Brave API for his net worth. And there we go, $400 billion, which is absolutely insane, but the right answer. So there we go. Our Archon agent is working perfectly, and we're just going to keep building out Archon as an MCP server, doing some crazy things with it. It's going to just keep getting better and better. Now that Archon can be integrated into AI IDEs as an MCP server, I have so many ideas to turn this into a massively powerful sub-agent to create other agents with my favorite frameworks. I just love that I can run wild with the agentic flow for Archon and not have to worry about the logistics of having it actually create and edit files, because the AI coders just take care of that for me now. So check the GitHub README that I have linked in the description for all the future plans that I have for Archon, or at least some of them. I mean, I've got so many ideas in my head. I've got things like self-feedback loops, or breaking down the agent creation down into smaller steps, a tool library, so many insane ideas. And if you have more suggestions yourself, or if you want to contribute, definitely feel free, because Archon is a community-driven project. So if you appreciated this video and you're looking forward to more things AI agents and Archon, I would really appreciate a like and a subscribe. And with that, I will see you in the next video.